This is an AS statistics question on the large data set. Helen is studying the daily mean wind speed for Camborne using a large data set from 1987. The data for 1 month are summarized in table 1 below. Here's table 1. Part A, calculate the mean for these data. So we've got a frequency table, so the mean is going to be the sum of fx over the sum of f. This is a sample from a table, so we should use the symbol x bar rather than mu. This is not the mean from a population or the data from a population. Now, this first column here, wind speed is not available. So I've got nothing to multiply that frequency by. So when I work out the mean, I need to ignore the value that's here. So I'll just cross that out for the moment. And then I'm going to do the wind speed times the frequency and then find the sum of those and then divide by the sum of the frequency. So I've got, and actually what I'll do is I'll work them out as I go along. So I've got 6 times by 2, which is 12, plus 7 times by 3, 21, plus 8 times by 2, 16, plus 9 times by 2, which is 18, plus 11 times by 3, which is 33, plus 12 times by 1 here, which is 12, plus 13 times 2, 26, plus 14 times 1, plus 16 times 2. Then I divide that by the sum of the frequencies. Now sometimes it's always worth looking in the question to see if the sum of the frequencies are given. It does say the data for 1 month, but I don't know whether that's a month of 30 days or 31 days. So I will need to add those up. So 2 plus 3, that's 5, plus 2, 7, plus another 2, 9, plus 3, 12, 13, 15, 16, 18. So actually it's not for a whole month, is it? Just for 18 days. However, I did disregard the frequency of 13 here, so that would have made 31 days, so that does make sense. So let's work this out on our calculator. Whenever you do this, don't do the whole thing in calculator and just write an answer down. Write out your working as you go along. So I'm going to work out the sum of the frequencies times the wind speed at the top, and that gives 184. So I've got 184. I need to divide that by 18, and that gives me 92 over 9. That's the exact value. I could give my answer like that, or I've got 10.2 recurring here, but you know, you can always go for 3 significant figures. So I've got 10.2. Now it doesn't ask for the units, so I can just leave it as 10.2. However, I can see that in part B it is asking for the units, and actually if you're dealing with wind speed is measured in knots. So they're the units we're going to be using when we get to part B, and part B is asking us to work out the standard deviation for the data. So standard deviation, now we could use the sigma symbol. Strictly speaking, because this is the standard deviation from a sample, I should use S. Strictly speaking, I don't think you're going to lose marks if you use sigma. Sigma really is for the standard deviation for a population, and this is going to be the sum of fx squared over the sum of f minus our mean squared. So what I'm going to do is just add another column at the top, another row at the top, where I'm going to write down my wind speed squared. That's like my x squared. So 36, 49, 64, 81, 121, 144, 169, 100, and now what's 14 squared? 196, and 16 squared, I think it's 256. So it's going to be my frequencies times by those x squared. So 2 times 36, 3 times by 49, plus 2 times by 64 and so on. So I'll just write that down. So because I haven't got enough space, I've just left out some of the in-between working, but I'll do that all on my calculator in a moment. So that's my sum of fx squared divided by the sum of f, the sum of the frequencies, which I worked out before was 18. And then from that I need to subtract my mean squared. Now I'm going to use the exact value squared, not my rounded value here. So never use rounded values in working unless the question asks you to. And we'll work this all out on our calculator and see what we get. Now that does give us an exact value of root 815 over 9. Now if I press my SD button and see what that gives me, so I got 3.17202. Let's go for 3 significant figures. So we've got 3.17, and it does ask for the units, so we'll put knots at the end of that. The means and standard deviations of the daily mean wind speed for the other months from the large data set for Camborne in 1987 are given in table 2 below. So given in this table here. The data are not in month order. Part C, using your knowledge of the large data set, suggest giving a reason which month had a mean of 11.57. So that is this month here. So we've got our high mean wind speed. So this is telling us that this is a windy month, but we don't know which month. Now we know that the large data set goes from May to October. Let's think about which of those months are going to be quite windy. Now May, it's like the end of spring, you're starting summer. It tends to be quite calm, you don't get storms, things like that. And then we've got over the summer. Then as we get into September, October, into autumn, it gets more windy. We get sort of storms and things like that. So I would suggest it's going to be October. Now we need to give a reason as well. So it's reasonable to say that October is quite a stormy and windy month because we're heading into, well, we're really into the middle of autumn. Okay, part D. The data for these months are summarized in the box plots below. That is the data for these months where we have months A, B, C, D, E, and we have the means for these months and their standard deviations are summarized in these box plots. We've got A, B, C, D, E. At the moment, we don't know which one goes with which because it says they are not in month order and they are not in the same order as table 2. So we can't assume that this one is A represents month A, month B, month C, and so on. They're all mixed up. What we need to do in the first part of part D is state the meaning of the asterisk symbol on some of the box plots. So I see some asterisk symbols here, and if you see an asterisk symbol, it just represents an outlier. Okay, so we can write that down. They represent outliers. Then the second part of part D says, suggest, given your reasons, which of the months in table 2 is most likely to be summarized in the box plot marked Y. So that's this box plot here. So let's just highlight that, or put a bubble around it. And basically what we want to do is to find which letter month goes with this box plot. And we do need to give a reason why as well. So I'm going to start by looking at the standard deviations and look at the spread of these box plots. So box plot Y doesn't have the smallest spread like the one above it does. So I would probably suggest that it's not going to be A because that has the lowest standard deviation, and this doesn't have like the smallest spread. Neither does it have the largest spread like this box plot at the bottom. So month E, which has the highest standard deviation, I'm going to ignore as well. So that leaves me with B, C and D. And I've come to that conclusion because remember, these asterisks are outliers, so I'm not considering those when I'm looking at the overall spread of the data. Now I'm going to look at the mean, and I'll use the median in the box plot to give me a rough idea of what its mean is. Okay, so Y has a lowish mean or median compared to the others. It looks like it's got the lowest median, so we're expecting the mean to be lower as well, and that leads me to believe that it's going to be this one here, because both C and D have slightly higher means. So I need to put my conclusion into words. So I would suggest month B, and I need to say why. So I'll write down, I'll suggest month B because the box plot hasn't got the largest or smallest range. We saw that. So if it hasn't got the largest or smallest range, I'm looking for a lower standard deviation, and its median is one of the lowest. So if it's got a low median, I'm expecting the mean to be one of the lowest as well.